All right, ladies and gentlemen, at this point in the program, we're going to have a discussion topic from science to sustainability, unlocking the power of DNA for Ghana's future. And to help us discuss this, we have very distinguished personalities who are here today to be our panelists. As the saying goes, ladies first. First panelist is Dr. Lydia Kwanzaa, HOD for the Department of Forensic Sciences. She is coming with a background and expertise of biotechnology. Please, let's receive her. We also have a renowned animal parasitologist, a molecular person for that matter. This person has a very great knowledge in animal parasitology, and we want to receive Dr. Francis Addy. We also have a seat. A panelist is Dr. Mohammed Safa. He is expertise of a soil microbiologist. Finally, let's receive Mr. Yahaya Sumara Sule, who is a DNA enthusiast. Let's put our hands together. As I said earlier, the topic for discussion is from science to sustainability, unlocking the power of DNA for Ghana's future, and to be the moderator for the session. We're going to have two sets of questions. We have the general questions, which we expect all our panelists to give us their view on, and then we will deal with specifics. So, ladies and gentlemen, one more time, let's put our hands together. All right, it is a very relaxed atmosphere. Welcome, ladies and gentlemen, distinguished panelists. We are grateful to you for taking time out of your busy schedules to be here. We hope that this discussion is going to be very insightful into our audience, in person and online. I just want to begin to know your views on this particular question. You all work in different fields, and so we want to know how your respective fields, in that field, how can the translation of scientific knowledge and advancement into sustainable practices contribute to the overall development and well-being of Ghana? I need to take that again, please. How can the translation of scientific knowledge in your respective field and the advancement into sustainable practices contribute to the overall development and well-being of Ghana. And I would want to begin with Dr. Mustapha, since he has seated right on my right.
Thank you very much. Thank you very much. Excuse my voice, I have some little. From my field of agriculture, sustainable agriculture is very important when it comes to the development of Ghana. Just to give a brief background, before the advent of the Green Revolution that involved before the advent of the Green Revolution that introduced the usage of heavy fertilizers that has led to the increased food production that has sustained the current global. Okay.
I think immediately you go back, so you have the position.
Yes. Yes, so in the field of agriculture, sustainability is very important when it comes to the development of any nation. And I was talking about the advent of the Green Revolution that led to increased food production that has led to sustaining the current global population. Now, over the years, there has been negative impacts of this revolution that is being reported. That is leading us to go back to the period before this Green Revolution. That is to adopt sustainable means of food production that will have less negative environmental footprints. So definitely pursuing the path of sustainability is very important. And in my area of research, we are pursuing this by exploring natural ways of rejuvenating the soils. That includes taking advantage of beneficial soil microbes for agricultural productivity while minimizing the impact of the chemical-based inputs that we use in our current agricultural systems. And I must say, in line with the theme of this sitting, the use of DNA-based techniques is taking center stage in exploring the beneficial soil microbes for the betterment of food production worldwide, including Ghana. Thank you very much.
Isaiah Sule, can we have your take on the subject?
Yes, for me, I don't have a lot to say, but I just remember when I was in level 300, Dr. Ali gave a lecture, and then he made mention of scientists allowing social scientists to communicate their science for them. So it resonates in my mind all the time. And I've grown to realize that doing that adds up to the available data that is within the system. So for me, I am not in a mainstream field of study, but then what I am currently doing is working with regards to getting data, which is very important to push the of study that I am interested in. So in doing that, since it is a good cause, I believe that it adds up to the sustainability base of everything.
Yes.
Thank you very much. I'm humbled that my co-panelist is bringing to them what I one time said in class. Those who have taught before, they will know that there are a few things I'm quite passionate about. And including science communication, particularly communicating science the way communicated, not downgrading the values of what we are communicating without understanding it. So the question posed to us on this platform is, what do I think about the communication of science in policy and practice? I am very much for it, particularly in the area where I do my research. I research animal parasites, their infectious agents. And so, of what use is it if I have understood the transmission dynamics or the genetics of the infectious, not translate into change in policy and practice, then I haven't done it. But that is the ultimate goal. All that we do in science, it shapes society, because the society we find ourselves in today have been grossly shaped by science, even when we fail to acknowledge the contribution of science to our society. Everything we do everything about modernization and civilization came as a result of science. And if the science had been on the table without being communicated and implemented, then what we know of common practices and common policies that govern our society today wouldn't have been in place. So yes, affirmative for this.
Okay, thank you. So, the little I will add is the fact that it is very important that we communicate science as it is. Currently, I'm teaching the level 200. I'm teaching the level 200 Introduction to Biotechnology. And one of the things we all know in Ghana, for instance, there is a lot of talk about GMOs, genetically modified organisms. But you could see that most of the people who are communicating this are people who are actually not science background. So they make it sound like it's very dangerous and all that. And one of the things I told my student in one of our lectures was that there are a lot of crops that currently we are eating. And it came as a result of natural mutations, something like cabbage, broccoli. They all came from wild mustard. Okay, they all came from wild mustard. So people would think that genetic modification doesn't happen naturally, but it does. So if we get the people who know the science and then they communicate it very well, it will help. It will help in sustainability, in agriculture, and in many fields, because people will not be afraid of whatever we are doing. Okay, so it is very important that we get the right communication in order to achieve sustainability in our various fields and the way we want it to go. Thank you.
So to Dr. Mustafa, we all know we have soil microbiota, and so I'm wondering what role do they play in
Thank you very much. As I mentioned earlier on, now plants have generally evolved very intricate relationships with soil microbiota. So sometimes the relationship between plants and the microbiota can be beneficial. It can also be detrimental and in some cases neutral. So the essence or part of our work is actually to harness the beneficial soil microbiota benefit of agricultural productivity. So in this line, the plants themselves have evolved mechanisms to actually recruit the beneficial soil microbes while excluding the detrimental ones. But of course, the microbes also have got their own mechanisms of escaping some of these barriers that are put in place by the plant. So in this regard, for example, some of our ongoing works seem to seek to profile the soil microbiota within the rhizospheres of different plants that are subjected to different cropping systems. So when we are able to identify the treatments or practices that seem to concentrate beneficial soil microbes into the rhizosphere of plants, then farmers can be communicated to with regard to the use of those practices in order to harness the beneficial soil microbes. Now, we have aspects to where we identify these microbes and you can actually isolate them. And that is what we now use as bio-inoculants, and some biofertilizers contain some of these microbes, such that when they are introduced into cropping systems, the plants have advantage of establishing the relationship with these microbiota. So in some way you are interfering with the microbiota with which the plants would have originally associated with. So in current terms, when you hear of regenerative agriculture or sustainable agriculture, it actually involves in most cases harnessing the beneficial traits of these microbes in agriculture while minimizing the use of the chemical-based inputs that we spoke about.
Excellent. That's really but just by way of clarity, you mentioned there is this relationship or interaction between the microbiota, soil microbiota, and the crops. How can this relationship be understood in the research?
Okay, thank you very much. I will use the case of rhizobium as an example. When we mention green legumes, what comes to mind is that they are able to fix nitrogen. Now, around the 17th century, when they isolated bacteria that could form the root nodules, all of them were termed rhizobium. So, with time and the advent of DNA-based techniques, we actually realized that not all rhizobium are the same. So, whereas all bacteria that could induce root nodules on legumes were referred to as rhizobium, the advent of DNA-based techniques allowed precise profiling of these microbes. That has led to presently we have about 17 genera of nodule-inducing bacteria, and each of them containing hundreds of species that are very diverse, distributed in diverse agroecologies around the world. And the list keeps unfolding. In our Ghanaian soils, actually, we have profiled a lot of rhizobium bacteria. Some of them are highly divergent from what is previously known. So now, when we carry out our subsequent works, we are likely to actually discover new species that are indigenous to our Ghanaian soil. So yes, the DNA-based techniques is revolutionizing the field of soil microbiology in terms of profiling them, identifying them, and describing most of them to the species level. Thank you very much.
Thank you very much, please. I think you want to show appreciation. I'll come back to you, sir. I don't want to stay with you for long. Dr. Lydia. As a biotechnologist, I just would want to know in which ways DNA technology can be is to combat antimicrobial resistance in Ghana, particularly in our healthcare settings. Thank you.
Okay, I think you can hear me, right? Okay, so the utilization of DNA to combat antimicrobial resistance has a lot of potential. In fact, so I guess we all know a little bit about antimicrobial resistance, is where now it started because of indiscriminate use of antibiotics. Okay, most of us use antibiotics without doctor's recommendation. We just, once you, most of the time, even nothing really, then we take antibiotics. I remember in my village, I used to visit my grandma, and then there was this man who goes around selling antibiotics. And they used to call it the ampicillin. And that was in the 90s. My grandmother would buy it. But you know, I didn't also even ask her why she's buying it. She just said, because her leg is paining her, then the man will recommend. He wasn't a doctor. I don't think he has even studied science. He was just selling. And I think it's not peculiar to my village. So antibiotics, which indiscriminate uses of antibiotics, then there has been the resistance of the bacterial diseases. So how can we utilize DNA? So basically, DNA will help in order to develop drugs, better drugs that the bacterials will not be able to be resistant to it. Okay, so basically, there are many other ways that DNA can be used, but basically, this is one of the things. In order for the biotech pharmaceutical companies to develop better drugs, drugs that will be able to kind of block the bacteria from being resistant to the drugs that will be administered. Okay, so this is how DNA revolution is being, and it's already being done. It's just that in Ghana, we are always behind, so we don't see it. But in the advanced world, it's already being utilized.
Thank you. Just to let you know, we will be taking questions from the audience, so you can start writing your questions. If there's anything you want to seek clarification on, kindly put it down. Once we open room for you, we'll take them and let them respond appropriately. Thank you very much, Dr. Lydia. Dr. Adi, because you are very much closer to her, I would want to come to you. And your work involves a lot of molecular characterization of parasites. And so how can we use that using DNA techniques? How can we use the work you do with the DNA techniques to contribute to the prevention and control of diseases? Livestock.
Thank you very much. I'd like to speak up. All right, so thank you for the question. How can the use of molecular characterization of parasites help in the I'll give you 101%.
Control of disease in livestock.
I'll give it 101%. Yes, absolutely is necessary because drug discovery or the process of developing drugs involve understanding the agents on which the drug candidates are expected to work. The big question is, how well do we understand the disease-causing agents in our environment? We all know that we are in sub-Saharan Africa. If you look at the biodiversity rate globally, we fall within a very high biodiversity gradient because we are on the equator. That leaves us with so much in our environment that we need to understand if we have to control the disease-causing agents. You would hear recently of neglected tropical disease. The big question is, why do we call them neglected tropical disease? Because they have names. And they have enlisted them with names. So it means that folks were not unaware of them. The only thing is that they were under-researched. So, if you go through it, the name itself even tells you that it falls within a certain geographical location, of which unfortunately we find ourselves. Neglected tropical diseases. We are in the tropics. So it means that this list has a lot of disease-causing agents in our environment included. And the big reason is they have been under research. We don't understand them very well. So the call for intensive research in that regard has been initiated by World Health Organization, WHO, and it's being championed in various ways by various institutions, by various individuals, including myself. What I do for research is basically characterizing several neglected parasitic disease-causing agents. And the question you are posing to me is how important that is. And I said it is 101% important because we need to understand these disease-causing agents. For instance, when you take a typical disease or parasitic agent that affects or that is prevalent in our environment, the pork tapeworm, I'll use that as an example. That's a common name, the pork tapeworm. It uses pigs as intermediate hosts and humans as final hosts. And so in environments or in communities where there is this common practice of open defecation and free-range rearing of pigs, then you are sustaining the transmission cycle. And globally, we know it as a pig or the pork tapeworm. Then we have a similar tapeworm in cattle. Recently in Asia, they have found a cross between the pig tapeworm and that of the cattle tapeworm, giving another species. So think about it. If the drug candidate on the market were targeting the pig tapeworm or the pork tapeworm or the beef tapeworm, and then now there is an intermediary species, a cross offspring between the two, chances are that the available drug candidates or drugs on the market may not be able to control this intermediary species. And the worst form of it is if this intermediary species happens to be more virulent, then we have a problem on our hands. And if no one is looking, no one will find anything. So we have to intensify and double our pace of work as far as molecular characterization of disease-causing agents is concerned. They call that intermediary species Tinea asiatica because they found it in Asia. It's possible we have Tinea africana, but we have to look to come up with one. That's all there is. Yes. So this is my preliminary answer to your question.
Thank you very much. Yes, so amazing you mentioned NTD and the fact that they are connected and they are with us already. And you are now mentioning this Kenya from here. A view that possibly we can have Kenya Africana, right? Yes, so, but then I just want to find out, are there some parasitic, like emerging parasites in Ghana that can be understood through DNA analysis?
I haven't come across one that I can share on this platform, but something that struck me in recent publication or in the media space, it isn't a parasite, rather a vector. But a new species of today in circulation in Ghana. That species, as I said, is a vector. Our audience, I'm not saying mosquito is a parasite. It's a snake that causes malaria. And this species of Anopheles that has been found in circulation in parts of Accra. What they know about it is that it is resistant to all the insecticides on the market. Yeah. So, if you are using mosquito spray, no. If you are using the coil, no. Except if you are sleeping in the net. The big question is, how do you ever sleep in the net? And so, this is a very big deal because we are in a hyper-endemic malaria region. And so, if we have these species of Anopheles in circulation and carry the Plasmodium falciparum around, that becomes a big deal. We have to find a way of controlling it. I'm citing an example outside of parasite because that is what is trending. And I said I don't have a readily available example to give when it comes to the parasite. But when it comes to emerging disease-causing agents, one of the smartest ways to find them out is using molecular tools. Because often they present morphology that looks like, wow, those that you are used to. And it is only when you dig deeper into the genotype that you realize that they are actually novel, they are different. And there you have a better appreciation of the genetic makeup of the organism. Because at the end of the day, any effort to control a disease, you are targeting a molecule. That brings it down to targeting something which is produced by the cell. And so, the good question is a chunk of the audience are bioscience students, so we can speak science freely. So you are targeting a molecule. Chances are that you are targeting a protein. And that proteins are not produced without the genetic information. And so, a better appreciation of the genetic information would, in the end, give us a better appreciation of the target agents or the target molecule that a pharmaceutical product could be used to control, or the effort or the strategy that can be employed. So yes, we have quite a lot in our environment. Even the endemic species of parasites in our environment, we have not yet understood them. We know of their big impact in society, but when it comes to the detailed understanding, we are far off. And there is this sad thing about diseases that affect the tropics. It will interest you to know that you mentioned diseases that are very important as in the country. Yeah, it's a sad reality. You look it up. There's a little list of experts on the various diseases, and you realize that some of them, there are diseases that affect the tropics, but the experts are sitting in the temple. So it means that with those, the disease are affected. If it doesn't affect you directly, it's affecting your relatives. Unfortunately, we are not the experts on the same subject matter. I'll end on this one.
Thank you very much. You've not spoken for a while. You are a DNA, forensic DNA. And so, what would you say about the utility of DNA analysis to the investigation of criminal cases in Ghana?
Criminal investigation is very important. And the use of DNA in criminal investigation simply because the DNA material in itself is that molecule that is capable of telling about who people are, even if they do not want people to know who they are. So, in the absence of any other evidence, when we get hold of DNA evidence, it means we are closer to finding the right person. So the use of DNA or the DNA applications in forensic science, in criminal investigations is very, very important. And one thing I would like to also add is that because DNA is individual inclusive, and then it provides the information that belongs to the person in question. We can not doubt the power of DNA in criminal investigations.
Okay, thank you very much. Dr. Mustafa, quickly, let me come to you. We all know there is soil microbiota, but what we want to find out is that are there any specific genetic markers of all microbial communities in Ghana?
Thank you very much. Now, when you say markets, now I will cite the 10 specific examples of rhizobium about. Now, there are diverse species, and some few years back there was a project named Learn2 Africa. The aim was to put nitrogen fixation to use in African farms. So we sought to use the intensive use of rhizobium inoculants. Now, whereas the science has been proven to work usually under controlled conditions, these microbes work very well. Under controlled conditions, when you try to harness the benefits of these soil microbes, it becomes a challenge because usually the benefits or the results are not reproducible. So you have a rhizobium bacterium in the grass now that produces. The following year, you may not be able to reproduce that. So it is seen that these microbes are diverse and they have certain properties. Usually, the positive effects of plants or these soil microbes can be direct or indirect. The overall aim of microbes improving the growth and productivity of the plant has to do with their role in making certain nutrients available. In the case of rhizobium, it can make nitrogen available by itself. But again, some of these rhizobia have certain traits. Some of them can help in solubilizing phosphorus within the soil. So that there is phosphorus which is not available, but the rhizobium, in addition to fixing the nitrogen for the plant, can solubilize the phosphorus and make it available. Not all rhizobium can do that. And then some of them can produce other growth hormones like indole acetic acid. Not all rhizobia can do that. So we do have molecular markers where you can profile a lot of rhizobium bacteria and detect which of them has the genes that make them capable of synthesizing indole acetic acid, solubilizing phosphorus, using siderophores, which are important when it comes to making iron available for plants. So these are some of the markers that are usually in the characterization of soil microbes. We try to profile them in terms of their abilities to produce some of these, to exhibit some of these traits. And interestingly, as Dr. Lydia was talking about antimicrobial resistance, now when I spoke about the issue of The challenge in harnessing the beneficial traits of soil microbes usually has to do with the fact that these are living organisms that are sensitive to various environmental stresses, drought, salinity, and also the presence of certain microbes that can be antagonistic to them. So yes, there are microbes that are antagonistic to the beneficial microbes that can actually produce antibiotics to counter them. In this case, we find it advantageous when you have bacteria, Rhizobium bacterium that is resistant or tolerant to penicillin, kanamycin within the soil. But when it comes to the issue of drugs and diseases, that becomes a disadvantage. So sometimes we tend to try to test which of these Rhizobium bacteria can withstand the most adverse conditions. And some of these adverse environmental conditions can be biotic and abiotic. So the biotic one has to do with antibiotic resistance and other. These are markers, some of them molecular and some of them biochemical, that we use to screen these microbes in order to identify those that are beneficial and also have the capacity to probably perform in adverse environmental conditions.
That's a very good one. And so, if I'm getting you right, when you were using Rhizobium, so Rhizobium or any soil micro targeted for land management in a sustainable way.
Land management. Now, if you are talking about bioremediation, there are microbes that can be used for that. Usually, have not come across Rhizobia, the use of Rhizobia as agents for bioremediation themselves, but indirectly, yes. Sometimes the legumes are used to reclaim depleted lands because of their ability to thrive in adverse soils, and that is supported by their ability to fix in association with these Rhizobia, so that in soils, old mines that have been depleted, sometimes the preferable crops to use to reclaim those lands are legumes. They plant them, and when they are able to form lymph nodes and fix this nitrogen, they grow, and then the biomass incorporates the heavy metals. Now, the issue is how to treat the biomass after it has been treated. But over time, when the legumes are planted, and in association with the Rhizobia, we are able to grow and incorporate the heavy metals within them. The soils are eventually clean. And what one of our students sought to do was to carry out such work over a period of time. And each year, the biomass is taken. We analyze the concentration of various heavy metals within the plant. That is likely to tell you over time when the soils are good enough for you to grow crops, then you consume those crops. Otherwise, you will be eating poison from those plants because they are actually contaminated with
Thank you. I want to come to you. You are an expert in metabolism, and you now head the Department of Forensic Sciences. So, can the merger of these two techniques help address environmental pollution, for example?
Yes. Very much. So metabolomics actually helps detect chemical compounds in any material, whether plant, human, anything that you use subject to. So depending on whatever molecule that you are looking at, which pollutes the environment, so you can use metabolomics to detect it. And then at the same time, we can now use DNA to look for microorganisms that can create this compound that is contaminating the environment. So these two areas can merge, and there is a high potential to merge metabolomics as well as DNA, because we can also use metabolomics also to, because once, so for instance, an industry which is polluting the environment with chemicals, basically it also becomes a political issue because it's kind of a crime. Okay, so then we can actually use the metabolomics as well as the DNA to find the compound that are contaminating the environment, whilst we use DNA to find microorganisms in order to isolate this compound. So the two areas can be made and they are very important. Thank you.
Thank you. So finally with you, I still want to stay, and this one is a question I've written for this one. Are there any ongoing initiatives in Ghana that demonstrate the application of DNA research to sustainable biotechnology? If there are, what are the outcomes?
So in Ghana, the problem is that we don't get our government supporting research. So my colleagues here who have research funding, they are all outside. From outside, outside. Some of us right, we don't get. It's okay, we'll get there. So it's a problem. Currently, the only, let's say, biotechnology products is cowpea, BT cowpea, which Siren has produced, and they are still on the way to commercialize it. Okay, which in a way is sustainable because it was produced against a pest, okay, that affects the crop. So in Ghana, we don't really get the funding. So most of the funding that we get are all international funding. Okay. The danger with the international funding is that sometimes they can dictate what you should do. Okay, so then you don't really do what will probably benefit the country, with quotes. But then if the government is serious for science development in Ghana with the use of DNA, then we can actually, because even with the SARI one, the funding didn't come from government of Ghana. It's an outside funding that they use to develop this digital. And then I'll come back to the communication because of the non-science people who are communicating. So there is a lot of confusion about even this. Okay, because people say it will lead to cancer development, which is it's not true. And even if we want to really see the dangers of if we produce GMO, if there are any dangers, then as a country we need to do it. We don't need to because Dr. Mustafa was giving an example where even with right, so if you grow them here in Yakala, first year you get a good impact. Next year it changes. So it tells you that there are a lot of changes going on, which means that there should be constant research in order to understand. Is it the environment? Because then you factor in everything. This year, what was the rain pattern? What was the temperature? Is that this what is happening? And then we can even tackle it at the DNA level. What DNA, what genes are being expressed, what genes are being turned on. Okay, so we get to understand all this through this research. But so the only thing that we develop which is sustainable towards sustainable agriculture is the BT cowpea that has been developed. But aside that, I don't know of anything else that if maybe I'll come for the health sector, but I'm not so sure talk about it as sustainable. There is a DNA company that is doing fertility tests. I think that's also one of the aside Inkaba, which is more towards the research, but there is a DNA company in Accra, I think in East Lagos, that is doing fertility tests, which is good because in Ghana we didn't have it. Supposedly they needed to send samples to South Africa. Even I think even currently still, right? But that most of the research you have to send to South Africa. So we need the research for the equipment because research in DNA is not cheap. Currently, Dr. Mustafa will say one prep for 50 DNA is 6,000. And that's a lot. So that's only for DNA. So if you are dealing with research, that will deal with RNA. Okay, to see the gene expression, that's even more. So there is a lot to do, but it all boils down to money for this research. So in Ghana, the only thing is that
Okay. So thank you very much. This question is in relation to growth, and so it is a general question to all of you, and I would expect you all will touch on them. How can the integration of DNA technology and research contribute to the achievement of SDGs? And here our areas of focus are on health, environmental conservation, agriculture, and justice. I think I wouldn't want you to touch on all the areas, so we can. I have about 5 areas here. Dr. Lydia, because of your area on metabolomics, I think you want to really touch on the environmental conservation part. And Dr. Adi, animal parasitology, so we want to touch on the health. And Dr. Mustafa, agriculture. So how can the integration of DNA technology and research contribute to SDGs in this area? Mr. Yaya, you want to touch on the justice, and I want to begin with you.
I wanted to start.
You wanted to
Something
start?
has come to mind that I don't want to say.
You don't want anyone to say?
No, not that I don't want anyone to say, but I don't want, I will forget. So.
That's fine.
Okay.
That's okay.
So I'm not going to talk only on environment.
All right.
What I'm going to talk about will have both on agriculture and also the health.
Yeah.
So because we've not done so much about DNA in Ghana, one of the research areas that now I'm trying to get the funding and look at is indigenous crops. I think those of us in Tamale, we've seen there are these local grains. They look like grapes. I think it's a local grain that I don't know if any of you, but it actually comes from tree. It's not from vines. So my area as a metabolomics, about a month ago, my supervisor, who supervised me for PhD, sent me a patent that he has done with collaboration. So what they did was that through DNA in the metabolomics, they found a grape that synthesizes higher amount of flavonoids. So they are making a tissue culture out of these flavonoids in order for health purposes, and they patented it. I believe that we have more indigenous crops in Ghana that can contain some of these compounds. So through the use of metabolomics and the DNA, that we can find, even for a lot of sicknesses and diseases that we utilize orthodox medicine that is not produced in Ghana. But because even our herbal medicine, we've not used research in order to understand it. And Dr. Adi already touched on it. If you don't understand the parasite that is causing the death, you will not be able to now find a drug for it. Okay, now we even hear about gene therapy, where they're actually targeting specific area, or especially with cancer, okay, where they are using gene therapy to cure it. We don't have it in Ghana yet, but it's always in the developed countries. So I'm writing a proposal. I have a few collaborators from UHAS, 2 of us from DME, one from food technology. So we are trying to profile, we'll start it with the metabolomics, profile indigenous foods. So we are going to do it in life. We'll start with indigenous foods, indigenous vegetables, and then we'll go to the, what do you call it, the root crop. Because there are a lot of indigenous crops that are even going extinct in Ghana because we don't use them. We are always the imported ones, even potatoes. My hometown, my grandmother was growing a potato in Fanti, in my language, which is Fanti, but we have a word, but we used to call it Abuedonu. Abuedonu means 100,000. That means it multiplies thousands. That plant is growing extinct. So that's one of the plant that I saw my grandmother growing that I don't see it in the market. That is where now I want to tackle it. and do research, because we don't, then it means that we don't even need potato, the average potato that is imported into the country. Okay, so these are the areas that as a country we will focus our research on, and then I'm sure we'll get a lot of it. Commercial production and then income for our farmers. Thank you very much. So I think
Okay, so Dr. Abi, I'll come to you, but ladies and gentlemen, at this point, yes, I want to acknowledge the presence of Akwenu is here. Let's and then we have Professor Saki also. Thank you very much, professors, for coming. All right, so Dr. Abi, please, how can the integration of DNA technology and research contribute to the achievement of SDG in health?
All right, thank you. Thank you very much.
If you want to touch on the other areas, you are free to do so.
Very well, thank you. I'll try. Still within the lines.
That's right.
Thank you, Dr. Watson, for setting the space. I think it is a very doable thing, and I look at it this way. First, to better understand the biological organism, be it the affected or the cause, the disease causing agents, or the population that the disease is impacting. They are both important, and using the DNA technology or the DNA research will help us to better understand our population and have a good appreciation of also the population of the disease causing agent, be it parasitic or bacteria, fungi, or viruses. A typical case in society is when COVID broke out, and the researchers in the University of Ghana decided to sequence the coronavirus. There they realized that we were having a lot of novel strains in circulation in Ghana. The big question is, if no one was looking, if they didn't take the step to sequence, because I don't think the government funded that they did it on their own to advise the government of what was in circulation, and that goes to say that looking at the genetic makeup of this organ, first you just want to understand, and then after you have understood it, you can now move ahead to the second step of innovating using this understanding. Because innovating blindly will just bring you back to the drawing board. You think you have hit the jackpot, only for you to implement your innovation. You realize that there's far much more that you don't understand. So yes, if the question is whether employing DNA technology in achievement of the SDG that has to do with health is essential. Yes, I say very much essential, and we can look at 2 ways. One, to better understand the disease-causing agent and even the population that these are affecting, and also to employ the DNA technology in innovating the therapeutic approaches that could be employed, both in drug discovery, for instance. We are hearing of these biotech interventions in like gene therapy. Of course, we have the argument for and against when it comes to gene therapy. We are also hearing of products that are being developed in we have transgenic organisms that are being used to produce proteins for pharmaceutical importance. So yes, we can employ several approaches in addressing SDGs that have to do with health, but we shouldn't leave the technology field.
Yaya, you want to touch on this?
Yes. So, with regards to justice, connecting it to the Sustainable Development Goals, it's in line with SDG 16, and SDG 16 has to do with the establishment of strong institutions and ensuring peace and stability in societies. And when we look thoroughly into this, you realize that there is something connecting it to fundamental human rights. Because DNA is an individual inclusive molecule. It can be used to solve a whole lot of problems with regards to fundamental human rights. If you look at sexual assault and all other issues related to crimes related to the DNA molecule. Now, I would like to look at human identification as one other area. As someone who is interested in forensic genetics and genomics, and I find interest in human identification, identifying people is very, very important. And you finding a place for every individual speaks a lot about you knowing where their fundamental human rights lies. So, if the DNA molecule is that molecule that can be used to identify an individual and find the right place for that individual, it helps in achieving sustainable development goals. And with respect to sustainable development goal number 16, it is an accelerator of all SDGs. And if sustainable development goal number 16 is achieved, all other sustainable development goals are achieved. Because if peace and justice prevails in a community, there is food, there is water, everybody can go out free, people can do what they want at what time. But then I also like to look at something that Dr. Adi said. How are we looking at it? How are we looking at achieving it? I don't know whether this might sound different, but are we only trained to be at the labs? So if the scientists are advocating, if the scientists are going out, if we have scientists in positions where we need, like Dr. Lydia said, she's been writing grants, she doesn't get. Probably it is not the scientist who is there. That person has no knowledge about science. So if we train scientists who can move outside the lab to find themselves in positions that can push science, I think that is one area that can enable the sustainable development goals to be achieved. Because if we are training scientists who are not focused on policy and advocacy, I think all the science will be dried up in the labs. And sustainable development goals might never be achieved. We might be going around it, but we might not be achieving it.
Very interesting. I believe it is very well said. Let's see what Dr. Abdullah has to say.
Thank you very much. Now, when it comes to the SDGs, the program is quite huge. Now, to put it in context, when the global population came early last year, we stood at around 8 billion. And by 2050, it is expected that about 2 billion people will be added. Now, half of those numbers will come from 8 countries. And 5 of those countries are in sub-Saharan Africa. So we are going to contribute more to the growth in the global population. Now, why is this important? This is the area where decline in soil fertility is quite high. Poverty is also high, so crop yields are much lower in these areas. And the SDGs with agriculture, we are now talking about how to feed the growing human population to ensure food and nutritional security. Now this means that this is the area that requires much research into finding ways of sustainably increasing crop production to feed the population that is going to be created. And yet we invest the least in research. When I did my checks a few years back, in fact, Ghana's contribution to research, science and research was less than 0.1%. Meanwhile, the AU's Agenda 2063 was sought to encourage African countries to increase. So 2063, Agenda 2063. Countries in Africa should at least spend 1% of GDP on science and research, and we are less than 0.1. So if you take countries in Africa like Egypt, South Africa, that invest a lot in research. South Africa was investing about 0.8%. And if you see the massive works that is coming out of this 8%, and their aim was to increase it to 1.5% of GDP by 2020. I'm not sure if they've reached there now. 1.5 is the amount that is spent by Europe to America. They spend between 1.5 to 3% of their GDP. So that's where the scholarships and other things we get, including the grants that we obtain, come from. So it tells you that as a nation, we really have not put in place the mechanisms to let us create our own research agenda and follow it, the way Dr. Lydia was saying. So efforts are fragmented because donors come with their own objectives. So you have to write your proposal to fit into their objectives so that you get something to do. I gave an example of the N2 Africa project that sought to say that, okay, African farmers, the smallholder farmers in Africa are quite poor. Their aim was, let's encourage them to grow legumes because they will not need a lot of fertilizers so that they can harness the beneficial soil microbes like rhizobium for the productivity of their farming system. That will lead to increased yields and whatever. All the bacteria that were being used as inoculants were USDA strains, some of them coming from Brazil. Meanwhile, some of the works we've done over the years show that Ghanaian soils and other African soils actually harbor novel rhizobium species that are highly effective when compared to the strains that have been used in this project. And up to now, even most of the inoculant producing companies in Ghana are producing the foreign-based inoculant. Why? Because we lack the funding to carry out our own work to profile the strains that we have in Ghana and utilize them. Because when it comes to adaptation, the chances are that because this is their natural environment, they are more likely to be adapted so that you can obtain that reproducibility that I said was the problem. A clear success of inoculant usage has been recorded by the Brazilians because they have used indigenous strains from their place. That is saving them millions of dollars in terms of fertilizer usage. So here, like I mentioned, people, we describe the bacterial strains and get to see that these are novel. But when you look at the cost of profiling them and describing the species level, unless you are funded by an outside, you will not be able to do it, because that requires whole genome sequencing and other things. So you shy away from those ways. So I think that yes, the DNA-based techniques actually hold the key to unraveling or to creating that sustainable environment for food production via harnessing the beneficial traits of these microbes. Not that alone, even on the plant part, while you are talking about food production, you are talking about the soil in which the plant is going to grow, as well as the plant itself. So when it comes to crop improvement, instead of the conventional breeding techniques that takes quite a lot of time to achieve results, these days you are able to adopt gene editing techniques in order to jump the queue and shorten the period which you use to improve a particular crop. And DNA-based techniques are not cheap. And with this our less than 0.1% contribution to research and science, we are not going to achieve that anytime soon. So those are the challenges. Thank you. And yeah, before we end, okay. Underutilized crops, Dr. Lydia. I work mostly with underutilized crops, even with the green legumes I deal with. When I was doing my studies, I decided to put aside all the crops that are getting the research attention, like cowpea, soybean. So I work with Keston's groundnut, Gambara groundnut, and recent times the salt bean and the jack beans. These are indigenous legumes that are nutrient dense, and they are able to thrive, because they've been neglected. They've been continuously cultivated in poor soil, so they've evolved to be quite adapted and are nutrient dense. When you look at the yield potential of some of these legumes, you will be surprised as to why we are not producing or promoting them. And when we were trying to, I sought to do work to identify novel species of bacteria that could be described the species level so that we can obtain inoculant strains from Ghanaian soils. I decided to use these underutilized legumes. So you could see that they associate with much more novel species compared to those that are continuously being So maybe I will leave the rest for later. Thank you very much.
Thank you. All right, so I'll come back to them for my last round of questions to our panelists. But at this point, we want to take your questions, and as I said, you just have to be brief about it. So let it be straightforward. We are taking just 5, and all of them in person. So let your hand go up, the mic will come to you, and we are picking one from each. Are these column or rows? Maybe okay, so columns. All right.
Good morning. My question is, what are the current limitations?
So please, if your question is directed to any of the panelists, you are free to do so. So that we can, but in general, let us know.
So my question is a general question.
All right.
But I have another one very short.
No, you have only one, so decide.
So I want to ask the general question. So what are the current limitations in future? What are the current limitations and future prospects of DNA diagnostics?
Yeah, so I think we just to move very fast. We want to respond to them, and then we'll take the second one. So, is any of my panelists ready to? It's general. So
Okay. Instead of talking of the limitations, I would say instead of the limitations, when it comes to the power of it, I would rather talk about possibilities. are quite endless. But in our Ghanaian context, I would just say, despite the endless possibilities, lack of funding is a limitation. But that limits your ability to, because whatever you imagine, you just explore DNA and you can find. But when you are limited by funds to carry out the research, then you tend to narrow your scope.
All right.
Add to what Dr. Mustafa said, I would like to talk about what do people know about the DNA? What data do we have? Are people aware about the endless opportunities of DNA? So that is also one thing that we need to be looking at.
All right, thank you. Can we have another person responding?
Yes.